We now continue the story of trigonometric ratios with some questions, so we can get ahead with the chapter. So trigonometric ratios, let's say we have a question like this. This is a triangle, as we can see. Given that AB equal to 3 centimeter, BC equal to 4 centimeter, and we have to now find all 6 trigonometric ratios of the angle A. This is the question. It's a very simple question. We see 3 centimeter and 4 centimeter. It's obvious through the Pythagoras theorem that this is going to be AC square equals to AB square plus BC square. AC square equals to 9 plus 16. AC square equals to 25. AC equals to 5. So AC is equal to 5. We get AC equals to 5. Now we get to the trigonometric ratios of the angle A. Now the angle A, this is the angle A between the hypotenuse and the side AB. So this is going to be considered as the base, and this is going to be considered as the opposite or perpendicular, this side, and this is got the base, and this is of course the hypotenuse. So now sine A equals to perpendicular or opposite upon hypotenuse. Perpendicular is 4, hypotenuse is 5, so sine A equals to 4 by 5. Cos A, base by hypotenuse, 3 by 5. Tan A, perpendicular by base. Perpendicular is 4, base is 3, so 4 by 3. Tan A is also sine A by cos A. If you do sine A by cos A, we get 4 by 5 divided by 3 by 5, which comes out to be 4 by 5 into 3 by 5. This is the way it is written. This goes up reciprocated. It comes out to be 4 by 3, which you also get by perpendicular upon base. And then the other 3 ratios are cosec A, sec A, and cot A, which are the inverses of sine A, cos A, and tan A. So sine A, cosec A is going to be 5 by 4. This is going to be 5 by 3, and this is going to be 3 by 4. Cot A, this is going to be 3 by 4. We got to know how these ratios are calculated, and then we can also do it by this upon this and that upon that way. So this is the first question which we should know how to solve. It's a very simple and basic question. Now it is not very just to directly get to such a question, but The bigger questions we solve, the more ways of solving, the more concept we can clear at the same time. And we do not have we have a time limitation of 15 minutes. I mean, I have a limitation of 15 minutes. So I'll take a big question this time. So let's go. This is not such a big question, it's a small question, but compared to the earlier one, it's a little big. So this is a triangle ABC, right angled at C, tan A equals to 1. Verify if 2 sin A cos A equals to 1. It's a very simple question. A triangle ABC, right angled C. So we make a triangle ABC. Right angled at C, so we write C here, A for ease of doing it, and this is B. So now this is the angle A. Given that tan A equals to 1. Okay, tan A equals to 1. Now let's say we have to get, basically to solve this one we have to get the value of all the sides to solve this question. So tan A equals to 1. Let's say that these two are x. We have to get the value of hypotenuse through the Pythagoras theorem, using Pytha. AB square equals to AC square plus BC square. X square plus X square equals to AB square. AB equals to 2x square. So AB square equals to 2x square. AB equals to root 2x. So AB equals to root 2x. Okay. So these are the sides, x and root 2x. To get this, I don't know what purpose is tan A equals to 1 actually serving, but let's use that in the question if we can. So there's the only way to use tan A in the question, and we have actually used it without mentioning it. I'm sorry for that part, that I used tan A equals to 1 without mentioning it. Tan A means perpendicular upon base. Perpendicular upon base. Now the perpendicular here is BC and AC. BC by AC, tan A. Now tan A equals to 1, so BC equals to AC. This goes here. So BC is equal, since BC and AC are equal, it can be put to be equal to x. That's what we have done here. Now we have put these two to be equal. I am very sorry that I did not have used it, but I did not mention it. I am sorry for that one. This is the first step, first of all. Step 1. And here, step 2. Root 2x. Now to get all the sin A equals to perpendicular upon hypotenuse. Perpendicular is x, hypotenuse is root 2x. Cos A, again base upon hypotenuse. Now we put it here. 2 sin A cos A and this root 2 into root 2 equals to 2, and x into x into x into x all gets cancelled, equals to 1. That's what we have to verify here, and we verified it. We will quickly do a similar question just like this one, so there's a lot of so that you have some clarity. Now again, there's a triangle ABC, right angled at B and tan A equals to 1 by root 3. Oh. Tan A equals to 1 by root 3. So now we have to find cos A cos C minus sin A sin C. Remove the triangle. Now here, of course, tan A. Here's the angle. For it, this is the base, and this is the, for angle A, this is the base, and this is the perpendicular. Tan A equals to 1 by root 3 equals to perpendicular upon base BC by AB. So root 3 BC equals to root 3 BC equals to AB. These two can be equal, or we could have done it from here. It would have been simpler from here. But now that we have written this step, these two can be equal only when BC equals to x and AB equals to root 3x. So root 3x equals to root 3x. So BC equals to x. AB equals to root 3x. It should not be over the x, this root, this sign, only above the 3. So now BC equals to x, AB equals to root 3x. After this, we follow the same steps like in the previous question. The absolutely same steps. Only this time, we have to take it from here. For this angle, this is the base, and calculate accordingly. We have to employ both these angles, angle A and C. We have to employ both these angles and calculate accordingly. We'll do it very quickly here. Cos A. Cos A is base upon hypotenuse. Now, no, wait. We have to calculate the hypotenuse also. So, root 3x whole square plus x square equals to AC square. 3x, it's not going to 9, equals to 3x square plus x square equals to AC square. 4x square equals to AC square. 2x equals to AC. So this is 2x. Now cos A cos C, base upon hypotenuse, root 3x by 2x, cos C, base upon hypotenuse, x by 2x, minus sin A, perpendicular upon hypotenuse, x by 2x, sin C, perpendicular upon hypotenuse, root 3x by 2x. We can see that both these quantities are same, equals to 0.